One of the things that flat earthers get told often is that they don't understand physics. It evades them like an offshore bank account does taxes. So when D Marble made a video responding to all these people that accuse him and others of not understanding physics, I watched with interest. Hello all and welcome to another episode of Flat Earth Friday with me, Simon Dan. Thank you very much for joining me. Before we begin, I'm delighted to announce that today's video is once again brought to us by Amino, a clever little app that provides interest-driven topics in short bite-sized video formats that also rewards creators too. I've uploaded my second story now and it's a lovely little globe proof. You should check it out. Here's a quick clip. Hey there, this is my telescope and I can use it to look at stars, planets, galaxies and nebulas. To find me, simply type in Simon Dan like so, then click the follow button and you'll follow me. Then you can keep up to date with all my stories and globe proofs. Just remember to turn on those notifications. Searching for stories is easy too. Just chuck a keyword into the search bar, check out the topics before selecting a story, like this lovely little sunset at the beach. A flat earth killer if ever I've seen one. Right, back to D Marble and his response. Let's see if he really does understand physics or if it's some gimmicky response as usual.
One of the comments that I always get in these flat earth videos that I'll upload, typically the ones that I'll do about the movements of the celestial bodies or gravity, one of the responses I always get from these globe believers, the more triggered ones, is you don't understand physics.
Well, that's probably because you don't. Unless you've studied physics past school, then it is quite difficult to understand it. And I guess that you haven't, D Marble.
And my response is always pretty much the same. I'm like, oh look, another physics expert. Well, here, how about this, genius? Go ahead and explain the physics of liquids or water in large quantities.
That would take some considerable time. The fact that you think it's easy to just explain fluid mechanics in a few sentences is just laughable and tells me that you do indeed fail to understand physics.
Now, do they ever do it? No. For some reason or another, globe believers like to tiptoe around that particular aspect of physics. So
the problem is asking people to explain to you the physics of a liquid when you yourself don't understand it is very much like asking Gordon Ramsay to teach you every single dish he's ever done in 10 minutes.
Let's do a quick check on understanding, a real simple rudimentary exercise, and then we're going to look at physics real quick. How about that?
Sounds exciting. Let's do it.
Now, what do you see here? A globe. B, a bowling ball. C, a spherical balloon.
Oh, I know this one. It's a globe.
A globe.
Yes!
Moving on. Now, what is the most prevalent surface color on this globe? A, white. B, green. Or C, blue.
Blue.
Blue. Very good.
Get in.
What does the blue on the globe represent? A, land masses. B, water. C, lava.
Easy. I believe this one is water.
B, water. You would be correct if you guessed B.
3 out of 3. Come on. I like this.
Under what state of matter is water classified? A, a solid. B, gas. Or C, a liquid.
That would be C, please, D.
And if you chose C, you are correct.
Boom! Unstoppable.
Now, let's take a look at the conclusion here. Most of the Earth's surface is covered by liquid. That's what we just established by answering those questions. Still with me?
I am, but we didn't need that little quiz to understand that. I think you were being a little bit facetious.
Good. Now, let's take a quick look at a short video outlining the physics of liquid.
Liquids seek their own level. Let us perform an activity to show that liquids seek their own level. Take a series of interconnected tubes of different shapes as shown here. Pour colored liquid into one of the tubes. Observe that the liquid stands at the same horizontal level in each tube, even though the area of cross-section of each tube is different.
What is this proving exactly? I'm getting very tired of this proof. What's hilarious about it is that water finds its own level because of gravity, something which D-Marble doesn't invest in. But what happens when there are forces involved that are stronger than gravity? Does water find its own level then? No, it doesn't. And what's important is that level that it always seeks is not necessarily always straight or flat.
We know that the pressure at the top of each tube is equal to the atmospheric pressure. Similarly, the pressure at the bottom of each tube will also be equal. Hence, liquids seek their own level.
Okay, so to go along with that, here's an example. Here's a cross-section side profile of the Panama Canal. Now, what you can see is on the far right side, it shows the Pacific Ocean at sea level, which you can see is pretty much flat on the surface. And then what happens is the boats move across Panama through a series of locks, rising and lowering the level of the water, moving across the landmass, and then coming out to the other side on the Atlantic Ocean, which is also at sea level.
Of course, what D-Marble has failed to point out is that the water level on the Pacific Ocean side is actually 20 centimetres higher than that of the Atlantic Ocean side. I wonder why he's omitted that.
Now this side profile here shows that, in correlation to what we just saw as the physics of water, that the surface of water is always flat. That water, liquids, seek to find their own level.
Yet you can't see the Atlantic side from the Pacific side. Oh, there's a ruddy big mountain in the way, you say. Well, the highest point in and around the Panama Canal is about 95 metres, so why don't you hop to the top of that and take a photo of the Atlantic Ocean for me. Good luck with that.
Now, you in your own personal experience have never seen water do anything on the surface other than represent a level surface, as if a perfect mirror. Now, if the surface of water were bulging, such an effect wouldn't be possible. This whole mirror thing that we have going on right here, that's not possible if the surface is curving.
Why can't flat earthers grasp the size of the Earth? Why is it so hard to understand that the Earth is so big to us that we experience a landscape that looks flat? I've shown it before, but from a very close-up shot, this basketball looks flat. But of course, we know that it's not.
But then this is where people would make excuses saying that this particular body of water is too small and that there's not enough space to see the curvature.
Precisely.
So let's take into consideration what you're seeing here. This is the world's biggest mirror. It's the salt flats in Uyuni, Bolivia. This place is 100 miles across and about 80 miles wide. And after it rains, there's about an inch or two of water and it becomes a perfect mirror, as you can see here. That doesn't happen on a globe.
Except it does. I've got news for you, D. Still not big enough. 100 miles. Is that it? 0.4% of Earth's circumference isn't going to work.
That's entirely too much missing curvature. So you know the physics of water. Water seeks to find its level.
I think you've shown quite conclusively that you don't know the physics of water, by stating that water finds its own level is the entirety of physics of water.
And that's what the surface of level water looks like, right there. Perfect mirror. Accumulates and gives off that reflection, indicating that there is no curvature on the surface. This is one of my originals from a while back, and this is just to get you thinking about this stuff, the simplicity of where we are. Whether it's water in a glass, whether it's in a pond, a puddle, in a lake, or on the ocean, the surface is always flat and level. You need to take into consideration the fact that bodies of water only appear to curve in pictures that you will never be able to take for yourself.
Is it our fault we're too small to see it? Is it our fault that we can't just hop up to space and take a quick photo? No, it's not.
And that's the pictures of the entire globe. Chances are you're never going to go to space and be able to snap that picture. Neither am I. But what we know in our reality is that the surface of water is always level. So, I'll admit it that both of these models have their own flaws.
Oh, they both have their own flaws. Yet you accept the one that looks like a pizza. Right.
But you gotta ask yourself, which one of these matches your experience in reality?
Well, I've been to Australia and it wasn't all stretched and warped. So, the globe. Easy, that one. Right, that brings this episode of Flat Earth Friday to a lovely close. Thank you very much for watching. If you enjoyed it, then a like and subscribe would be thoroughly appreciated. I have been your ever-present host, Simon Dan. Have yourselves a great weekend, and I'll see you all on Tuesday for The World by Hans. Until then.